In this video, we'll be learning about how to interpret the graph of a function to obtain information about the function. Let's take a look at an example. In this example, we're given the graph of the function f. Let's try to answer the following questions. In A, we want to determine the output of the function at various inputs. One thing to keep in mind is that for the graph of the function, each point on the function represents a pair of input and output. So if we want to determine f of -1, we're asking what's the output of the function when the input is -1. So remember, the x-coordinate corresponds to the input, the y-coordinate would be the output. Since the input is -1, we want to go to our graph where the x value is -1. We see that we have the following point on our graph, -1, 2. Since 2 is the y-coordinate, that's the output that corresponds with the input -1. So f of -1 is equal to 2. For f of 0, we want to find the output of the function when the input is 0. So go to your graph where the x-coordinate is 0. We have this point here, 0, 1. The y-coordinate is 1, so that tells me that the output when I plug in 0 is 1. Next, we have f of 2. We want to find the output of the function when the input is 2. So go to our graph where the x value is 2, and we see this point here, 2, 0. Since the y-coordinate is 0, that's the output of my function when I input 2. Lastly, we have f of 6. We want to find the output of the function when the input is 6. So go to the graph where the x-coordinate is 6, and we see this point 6, -2. The y-coordinate being -2 tells me that that's the output of the function when the input is 6. So f of 6 is -2. Now in part B, we want to determine whether f of -3 is positive or negative. F of -3 is the output of my function when the input is -3. So just like our previous problem, we want to go to where my graph has the x value -3. This time there's no specific point labeled on our graph, but when x is -3, we have a point about here. At this point, the y-coordinate is positive because this point is above the x-axis. So the output of my function at -3 should be a positive number. In part C, we want to determine whether f of 4 is positive or negative. F of 4 is the output of my function when the input is 4. So we want to figure out the y-coordinate of our function when the x-coordinate is 4. So looking at our graph, again, there's no specific point labeled on our graph, but f of 4 seems to be about here. The point here has a negative y-coordinate because this point is below the x-axis. So f of 4 should be a negative number. We don't know what the specific number is, but it's negative. The next part asks, for which values of x is f of x greater than 0? So this problem is asking us, for which inputs is the output here positive? Remember that outputs correspond with y-coordinates. So we want to look at our graph and see for which points on my graph is the y-coordinate positive, meaning for which points on our graph is the graph above the x-axis. Let's highlight that portion of the graph that's above the x-axis. Now this problem is asking us for the x values or the inputs where this occurs. So the x value where this green region starts is at -4, and where it ends is at +2. So in interval notation, this is going to be -4 to +2. And what I'm going to do is I'm going to exclude the endpoints because at x equals -4, the y value is equal to 0, which is not greater than 0. And we have the same thing at x equals 2. The y-coordinate there is 0, which is not greater than 0. So when we write our interval in interval notation, we use parentheses to exclude those endpoints. In part E, we want to find the domain of our function f. Remember that the domain of a function are the inputs to the function, and the inputs correspond with the x-coordinates of the points on our graph. So let's look at the points on our graph and see what x-coordinates we have. Specifically, what I want to do is look for the smallest x value that's present and look for the largest x value that's present. To find the smallest x value in our graph, we want to go to the leftmost point on our graph. So the lowest x value here is -5. To find the largest x value in the graph, we want to go to the rightmost point on our graph. The rightmost point occurs at 6, -2. Specifically, the x value there is 6. Since we have a point on our graph for each x value between -5 and 6, the domain of our function is the interval -5 to 6, including those endpoints. In part F, if we want to find the range of our function, we want to look at the outputs of the function, and the outputs correspond with the y-coordinates of the points that are on the graph. Once again, we'll want to find the smallest y-coordinate and also the largest y-coordinate. To find the smallest y-coordinate, you want to look for the lowest point on your graph. The lowest point on our graph occurs here at -5, 3. So our smallest y value is -3. To find the largest y value on our graph, we want to go to the highest point in our graph. The highest point here is -2, 4. Specifically, the highest y value is 4. Since there's a point on our graph for each y value between -3 and 4, our range is -3 to 4, including those endpoints. In part G, we're asked, for which values of x is f of x equal to 0? So we're looking for the inputs for which the corresponding output is equal to 0. Meaning on our graph, we're looking for the x values for which the corresponding y value is equal to 0. Well, there are two places on our graph where the y value is equal to 0. At -4, 0 and at 2, 0. So our answer here is x equals -4 and x equals 2. For part H here, for which value of x is f of x equal to 4, basically we're looking for the input where the corresponding output is equal to 4. In terms of our graph, we're looking for the x value for which the y value is equal to 4. So go to your graph where the y value is 4. We have this point here, -2, 4. The x-coordinate there is -2. So our answer here is x equals -2. So in this video, we learned how to look at a graph of a function and obtain relevant information about the function. The most important thing to know is that for each point on our graph, the x-coordinate corresponds with an input, the y-coordinate corresponds with an output of your function.